Hello everyone, my name is Vivek Port. Welcome back to my YouTube channel, Better Call Paul. So in this video, we will going to learn about decision trees. This is one of the machine learning algorithm, and I'm planning to create a playlist of machine learning algorithms where each and every most commonly used machine learning algorithms we are going to see. So in this today's particular video, today is 25th of January 2026 and 11:40 p.m. night time. And today we are going to learn how decision trees actually work. What is the concept decision tree? What is the algorithm? What is the flow chart behind the scene? What kind of mathematical formulas are there when we are dealing with decision trees algorithm? So not only theoretically, but also practically, I will explain you about decision trees. I will explain you using this pen and pad. I have bought this pad and I have bought this pen also. This is a branded quality pen and pad, and by writing uh, means with the help of my handwritten notes, I will explain you what is decision tree so that you will get in-depth clarity. Means there will be very less confusion after viewing this entire video. So stay tuned. And what is basically decision tree is that if we have a huge data set is very required to deal with any kind of machine learning project, data science project, to get the insights from the data to predict the next outcome from the data. So if we have a historical database, then maybe we have a class categorical outcome, or maybe we have a numerical regression outcome. We can decide the next output by using decision tree. How decision tree works, for example, if I am a bank and you are a customer, you want to take a loan from a bank, then as a bank manager, as a human, how can I decide? I will check your various parameters. I will first check your income. I will first check your job, whether what is your income source, whether it is a job, government job, private job, self-employed, unemployed, uh, or salaried person, whatever it is. Then income, what is your income range? It is a low income range, medium income range, high income range. What is your age? Young, senior citizen, or middle age? What is your credit score? We know that a CIBIL score. So what is the range of your CIBIL score, or is it a good CIBIL score or bad CIBIL score? Uh, Various parameters I have in my data set, banking data set, and from that I will decide. So, for example, if we have, and uh, this is like asking questions to the database and getting the answers in terms of yes, no, positive, negative, good, bad, or maybe in a numerical format. But the decision tree splits the data set into various branches. So you can say that it is more like a classification algorithm. Uh, Classification in terms for example, if we say that whether to buy a stock or not, whether to give loan or not, whether to means there are a lot of things, whether this email is spam or not, whether to hire this particular candidate or not. So how humans decide, does the person have income? If yes, then is his credit score is good? If yes, then is the risk is very high or low? If yes, and so on. Means question, answer, next question, next answer, next question, next answer. It is splitting like that, and we come to a certain particular answer. So, for example, if you have 10,000 rows of data set, then we will reach to another answer by skipping 300 rows. Now we have 700 rows. Now we will again ask another question to that data set. Then that 700 rows will shrink to 400 rows. Again, we will ask some question. So like that, the decision tree works. It splits the branches and it reaches to another answer. So, and a simple definition of decision tree is it is like a flow chart like model. It asks questions to the data, splits data based on the answers, reaches a final decision at the end. And here we have root node, internal node, leaf node, branches, first question, intermediate decision, final output prediction, and answers to question. It has a classification tree model or regression tree model, whether our output is in yes or no format, spam, not spam format, buy, sell, hold format, or it may be a regression like numerical format. The house price is 45 lakh rupees, for example, and who will buy the house, whether the person is having salary more than 12 lakh LPA or less than 12 lakh per annum LPA, 12 LPA. So the salary is in the numerical format. Then it comes a regression, but it is a regression decision tree. Like that, it happens. And here we have two parameters like one is entropy and one is information gain. How entropy works, how to calculate entropy, how to calculate the information gain, and from this overall how to decide to move forward with the decision tree, we will see uh, on my pen and paper notepad. So stay tuned. I will switch to another screen. So this is our one notepad now. And look at this. This is our data set where we have IDs of the customers, we have income column, credit score, age, employment, loan approved. So the column names are very important when you are dealing with any kind of data science project. So this is decision tree algorithm. So whether what is the income of that person? So maybe whatever may be the income of that person, we have converted into some categories. Uh, if his income is more than 2 lakh, then it is like high. If it is income is in a range of 1 to 2 lakh, then it is medium. If it is less than 1 lakh, then it is low, or whatever maybe it is. So we have converted the numerical factors into categorical factors. Here is a credit score. What is the credit score? What is the back history of his repaying to the loan? It is good or bad. Two categories are there. It is the age column is also there, young age, middle age, or senior citizen age. Then comes the employment column, whether he is employed, self-employed, salaried, unemployed. There are one, two, three, three categories are there. Then loan approved, yes or no. Two categories are there, right? Now, the main factors of this decision trees are one is entropy, second, and one is information gain. So, what is entropy? Entropy means it is when we the first time I listened this entropy word is from my thermodynamics lectures in engineering degree. So, what is entropy? It is the degree of randomness. If you closely look at this loan approved column, this loan approved column, yes, no, yes, no, yes, no. So if all the cells are yes, then it is pure. Means we can say that everyone is there. Means the bank is approving loan to everyone. So it is a pure. Means there is no entropy. There is no degree of randomness. So zero is the entropy. No entropy, zero randomness. So zero. So if all are yes or all are no, means all are same, then there is no disturbance. It means the entropy is zero. But if some are yes, some are no, then there is a degree of randomness. There is a degree of some kind of disturbance we are seeing in that output cell. That's why the entropy is not zero. It is something. So entropy is in between 0 to 1. Now, if half of the rows are having yes and half of the rows are having no, then it means that the entropy is 1. 1 means there is a huge mismatch in the data set, means half of the rows are yes, half of the rows are no. Now it comes our part. to sort out this degree of randomness and to approach a particular strong decision. And now information gain. What is information gain? Information is now whenever the entropy is more than zero, then we are trying to split a branch. We are trying to split the database. And how good is the split is what information gain is. So these are the definition of entropy and information gain. Now, what is the formula? Here entropy is 1 because 1, 2, 3, 4, 5 and 6 are yes in lone approved column and 6 are no's in lone approved column. Half yes, half no, that's why it is 1. If all are yes or all are no, then it is 0. And the formula of entropy is summation minus is the formula of it is minus summation of probability log to the base 2 and that probability. Now here probability the probability of entire data set is what I will explain you. And information gain, the formula of information gain I will also explain you. Here the formula of information gain is entropy of parent minus entropy of children. Yes, this is the entropy. And entropy of parent means entropy of the entire data set minus entropy of the children means entropy of that particular decision trees branches. So what is the entropy of parent? Entropy of parent or entropy of data set. What it is, we will see. Well, first of all, we will see means I have told you that minus summation of probability of log 2 of probability. Now we will calculate the probability of yes or and probability of no. So probability of yes is equals to total yes divided by total of yes plus no and whatever present yes, no or null. So total yes divided by total. It is like right. So what it is? 6 divided by 12, it is 0.5. Okay, it is probability of yes. Similarly, probability of no, it is 6 divided by 12 because 6 no's are present 1, 2, 3, 4, 5, and 6. And total yes plus no are 12. So it is 0.5. Now it comes entropy of the entire data set is minus of probability of all. I will explain you. Entropy of the entire data set means entropy of yes plus entropy of no. So minus entropy of yes is 0.5 into log 2 of 0.5. Here it is, we can see probability into log 2 of probability. So probability 0.5 into log to the base 2 of 0.5 plus entropy of no 0.5 log to the base 2 of 0.5. Okay, so what it is, we can say that the entropy of if we paste this on internet, then we will see that it is 0, that it is 1, sorry, 0 means pure, 1 means completely unpure, means it is mixed, half yes, half no. So I will show you it. You can see here, I just paste it on Google Chrome and hit enter. So it says the solution is 1. 0.5 into log to the base 2, 0.5 plus 0.5 into log to the base 2 of 0.5. The answer is 1. Okay. So the entropy of the entire data set is 1. Okay. Now I will just write down over on the top entropy of data set is 1. Okay. This is we have calculated. Okay. And I will just remove this. Um, We go here. Okay. Okay. So I have removed this. Now what we will do, we will split it by income. Income is the first column. We will check by income. If his income is high, then loan approved, yes or no. If income is medium, then loan approved, yes or no. If it is low, then approved, yes or no. We will see. So by income, split, just 1 second, split by income. Okay. So here in the income column, there are four high. Yes. So income is high. For example, income is high. Then yes are 4. No are. Okay, 1 second. No are 0. So here we can see the entropy is equals to 0 pure, because earlier we discussed all are same, then there is no randomness, then entropy is 0. And now if income is medium, then how many yes are there, how many no's are there? So medium income we see 2 yes and 2 no, 2 yes 2 no, half of yes are no, what, half are yes and half are no. That's why the entropy is equals to 1. Okay. Now here we will see if income is equals to low, then yes and no. Yes are 0 and no are 4. 0, 4. So entropy is equals to 1. Sorry, entropy is equals to 0 because all are same. This is about income section, right? Now we will calculate the weighted entropy of income section. Okay, so weighted entropy. Weighted entropy is equals to uh, how many rows are there in high section? There are 4 rows. In medium section, there are 4 rows, right? And in low section, there are 4 rows. High are 4, then medium are 4, then low are 4 rows. You can see 4 rows are there. So how many rows for high? 4 out of 12 rows. Multiply by what is the entropy? 0 for high income group, plus for medium, there are 4 rows divided by total rows multiplied by what is entropy? 1 for medium. And for low, there are 4 rows multiplied by divided by total rows multiplied by what is entropy? 0. What it is? 0.33. You can calculate 0 plus 1 by 3 plus 0 1 by 3 means 0.33. So 0.33 is the weighted entropy of this income group. Okay. Now, what is the information gain? We see information gain is parents entropy minus child entropy. What is parents entropy? 1. So here I will just what is the information gain is equals to parent entropy 1 minus 0.33. It is the entropy of the child. Child means one column, you can say. Now we are considering income column. So income is our child. That's why information gain is 0.67. Okay. So information gain means it is like a weightage you can consider. This much knowledge we can gain from this particular column, which is income column. This income column is that much high importance. It this is you can see the power of this statistics, the mathematics. This information gain formula uses the weightage, uses the importance of that particular column. So 0.67 is the information gain from this income column. Okay, yes. Likewise, we can calculate information gain and entropy from credit score, age, employment, and we can move forward. I will just remove the unnecessary part. Now the same we will calculate for credit score. Okay, split by credit score. Okay, I will just maximize it. Mm, okay, weighted entropy, the formula. Okay, um, here split by credit score. Now, for credit score, there are two columns only. Credit score equal to good, and here credit score is equals to bad. So, how many credit scores are good? One, two, three, four, five, six. So, six rows are there, and one, two, three, four, five, six rows are there. Okay. So, in that six good credit scores, how many yes are there for good? Five yes are there. One no is there. And for bad, how many? One yes is there and all no are there. One yes and all are no. Okay, now entropy. How to calculate the entropy? I have told you that yes divided by all multiplied by. So we are calculating for what? First of all, we are calculating for yes, then we will calculate for no. So 5 by 6 means this is probability multiplied by log to the base 2 of probability again 5 by 6. Now this is for yes, and here is minus sign plus probability of no. What is 1 by 6 multiplied by log to the base 2, 1 by 6 bracket complete. So it is equal to 0.65. I will show you how. If you go to Google Chrome, I will just show you. If you just go to Google Chrome, 5 by 6 log to the base 2 of 5 by 6. 5, how this 5 comes? Because 5 years are there. You can see 5 years are there. And 6, how it is come 6? Because 5 plus 1, 6. Uh, actual upon total, actual upon total. So actual yes upon total, total means yes plus no. So likewise, actual no divided by total, yes plus no. And probability multiplied by log of probability. This is equal to 0.65. How? You can see here in the formula. Minus of probability of yes plus probability of no. So it comes 0.65. So this is how our probability comes 0.65. The same we will calculate for what? For credit score bad, for bad credit score. Okay. So here we will go. First of all, I will write down here 0.65 probability for good. Okay. So this is now for and this is probability for good. Huh? Probability for good. Probability for bad is minus of yes, for yes we will calculate 1 by 6 rows are there, multiply by log to the base 2 of 1 by 6 plus 5 no are there out of 6, multiply by log to the base 2 of 5 by 6 because probability is same, and I think it will be equal to 0.65 because both are same. Now this is entropy for bad credit score, which is equals to 0.65 entropy for bad. Now what is the weighted sum of these? Weighted entropy of this. So weighted entropy of this is 6 by 12. 6 by 12 into 0.65. I will just remove it. Stuff out. Yeah. Okay. 6 by 12 multiply by 0.65 plus 6 by 12 multiply by 0.65, which is equals to 0.65. Okay. 0.65, and information gain is equals to 0.65. 1 second. 65 is equals to 0.33. So 0.35 actually. So this is information gain. So information gain of credit score. Information gain of credit score is 0.35. This 0.35, we get 35% of knowledge from information gain of from a credit score. So this is the weight calculation. How this 12 comes? See, 6 means there are 6 rows for good credit score and there are 6 rows for bad credit score. There are 12 total rows, good plus bad. So 6 divided by total means good divided by good plus bad, bad divided by good plus bad. And what is the probability of good? What is the entropy of good? It is 65%. What is the probability of bad? It is 65%. So uh, it comes to 0.65, and information gain is entropy of the entire data set minus entropy of the child parameters. Now here our child parameter is what it is, credit score. So 0.35 is the information gain for credit score. Now I will again remove all this, and here I will mention on the top IG of income is IG of credit score is, and IG of employment we will see, and here I will write down 0.35, and here for income I will write down it is 0.33. So information gain of credit score we have calculated 65 earlier. Sorry, from it is mistakenly wrong. For income it is 65. And for credit is it is 1 second. It is 35. Yes. Now information gain for another parameter I will calculate. For that I will remove this. I will just maximize it and mm, so this is our so by 1 second. Split by employment. So split by employment here we have employment, then how many years are there, then how many no are there. Employment, how what is salary? Salary, then unemployed, then self-employed. Now salaried, how many years are there? One, two, three, four. 4 years are there, and three no's are there. Here for unemployed, there are two unemployed, and in that two unemployed, both are no. And in self-employed, one, two, three columns are there, two yes and one no, right? So if we calculate, it is same. If we calculate the weighted entropy is 0.71 and information gain is 0.29. You can write down here uh, uh, information gain of employment is 0.29. So 29% information is gained by uh, employment column, right? And it is same for age also. Means weighted average for age is very low, and information gain is nearly 1. So if you calculate it, you can find out information gain from age is 0.1. So the most weightage goes to income section. Here income section, you can see it is the best. And we can split the decision trees. Now, for example, if we have income, this will be our most important tree. And below that, there are three sub branches. One is of high income group, one is of medium income group, and one is of low income group. Right? This is high income group, this is medium, and this is low. Why we give importance to this income? Why we decided to split against this income? Because this decision we take from information gain statistical term. The information gain of income category is the highest, 0.65. That's why we have decided to split through income section, not through credit score section, not through age section, not through unemployment section. We decided to split through income section because the information gain of that particular column is the highest among all the other columns. Now, if it is high, then then of course the answer is yes. If it is low, then the answer is no. And if it is medium, then there is a confusion. You can see from here. If it is high, then of course the answer is yes. But if it is low, then the answer is the output column is no. But if it is medium, then uh, for some 50% times it is yes, 50% times it is no. So how to decide this? How to decide this? So that is a question. This is mix. So we will split through this medium. So now the next stage is second level split is income medium. Rows where the income column is having medium salary range. Okay, medium income range. Now in medium range, you can see from medium the credit score is good as well as the credit score is bad. The age section is middle, senior, median, and senior is also there. Employment is self-employed. Salary is also there. Self-employed is there. And based on this, we decide loan approved yes or no. So now we will try according to credit score. If the credit score is good, then yes. If the credit score is bad, then no. Okay, for medium only. So I will just rub this. So you can clearly see whenever the income is high, then the possibility of loan sanctioning is always 100% yes. If income is low, then it is 100% no. And if it is medium, then 50% is yes, 50% is no. And in that 50% yes, no, if the credit score, you can see over here, if the credit score means in medium income group, if the credit score is good, then loan approved is always yes. So if the income in the median income, if the credit score is good, then if the credit if the credit score is good, then the loan approved is always yes. If the credit score is bad, then the loan approved is always no. You can check it via this database. If the credit score is bad, if the credit score is bad in the medium income range, then the loan approved is always no. So this is the strong, you can see. I will just draw this tree. Uh, it is blue line. I will just show you the how this decision tree works. So this is how decision tree works. So this is our first decision tree. This is our second decision tree. And now we have, yes, this is our third decision tree. This is our fourth decision tree actually. The third one is, yes. So this is our This is our third decision tree. So these are the decision trees. Strictly, if the income is high, then yes. If the income is low, then no. Then if the income is medium, then we will split the decision tree according to the credit score. Why credit score? Because second importance we have given to the credit score. It is second rank in descending order sorted, 0.35. If an employment category is more than 35 or it is in second priority, then we will choose for employment and we will split accordingly. So this is the division of the tree and this is how splitting works. And yes, we have taken decision to split the tree. And how this decision tree works, for example, if we get another customer, so I will just show you. If we get another customer who's having uh, income, uh, whose credit and employment and age. If we get these four columns, for example, income is medium, credit is good, and employment is salaried, and age is young, then how it will comes like okay, his income is medium, his credit is good, and that's why his loan approval should be yes. So based on these parameters only, income, credit, we will give him loan. Yes, it is done. So this is how decision works. This is the prediction. So this decision tree runs on the entire data set. Now there are some problems like over tree. Why decision tree stopped here? Because leaf nodes become pure and there is no like 0.35 or 0.15. It's strictly one or it is strictly zero. That's why a degree of randomness is no. That's why the decision tree stops here. No further information gain is possible. So business explanation. If the income is high, then approve the loan. If income is low, reject the loan. If income is medium, then check the credit score. If credit score is also here and there, then again check another column. And a real world business test case study is loan approval, credit underwriting, risk classification, rule based buy or sell the stock, healthcare diagnosis trees, HR hiring decisions, decision tree uses greedy splitting, entropy measures the impurity, information gain selects the best split, decision tree uses greedy splitting, prone to overfitting, pruning is needed, and very important is never stop at decision tree. Use it to understand the data, create rules, then move to random forest and execute. Means if you have a bigger data set, for example, thousands of lines of rows or what thousands of lines of means there might be millions of lines of rows, so it is not like only single and there are for example 100 columns are there, then it is not necessary that single decision tree gives you the better output. You will need multiple decision trees. You will need to run through multiple decision trees. Means, for example, if you have 10,000 rows and for 1,000 rows, there is a one tree, another second is second thousand rows there is another tree, third thousand rows is so there are 10 decision trees, one decision tree for 1,000 rows only, and the average of all these 10 decision trees is equal to the output of one random forest. Forest means the tree. Random forest is the average of multiple decision trees. XGBoost is also there. Means if your random forest is giving you the answer, but XGBoost is just correcting the errors of your previous decision trees, not only averaging the previous decision trees. So this is how the decision tree works. Now in scikit-learn library, Gini impurity is there instead of entropy. Both are almost same. To calculate the entropy, it is slightly lower because logarithmic calculation are there in entropy, which lowers the computational speed. But in Gini impurity, you don't use logarithm. You use the square of that particular probability parameter. That's why what it is. Gini impurity is faster. That's why it is by default used in scikit-learn library, and your entropy is not used in scikit-learn library. Accuracy of entropy is slightly better than Gini impurity, but it is almost same. To handle the larger data set, Gini impurities we use. Mm, and that's why and by default it is used. Speed is faster for Gini impurity, and formula is here log base, it is square base. And what is overfitting? What is overfitting? Overfitting means the tree becomes too strict to the parameters. For example, if the income is high, and if the credit is good, and if the age is young, and if the person is employed, then only use the loan. Otherwise, no. So if it becomes too specific, then it gives too specific answers, and it results in the bias nature, and it is like a overfitting, means it will not give you the good answers in your test data sets, and that is called as overfitting. Overfitting is very dangerous. How to avoid overfitting? Just split your data set into subsets and run various decision tree, average them, and the averaging of all the decision trees is the random forest. It gives you the output, and that's it. So now we will just recap what we learned in the entire course of decision trees. So what is exactly decision tree? Decision tree, it is a supervised learning algorithm that splits the data recursively using impurity measures. Now what is entropy? Entropy, it is a measure of randomness or impurity in the data set. What is the information gain? Information gain is the reduction in entropy after a split. And it is the knowledge, it is the importance given to that particular node of that tree so that we can decide which particular node we have to start split the next. We have to ask the next question to the data set. What is the difference between Gini and impurity? Gini is faster, entropy is more theoretical. Why trees overfit? They keep splitting until pure. That's why trees are overfit. They keep splitting until they become pure. How to prevent overfitting? We can do pruning, we can do max depth, we can do minimum sample. So we can restrict that maximum depth should be like this. The pruning should be like this. Minimum sample should be this. It is not necessary that 10,000 rows are there, then there should be 1,000 decision trees. No, there should be 10 trees or 20 trees like that. Minimum sample we can provide. Why random forest works better? Because it reduces the variance by averaging all the decision trees. That's why random forest gives you better results. Can decision tree handle categorical data? Yes. Can decision tree handle regression data? Yes, it handles. Does decision tree need scaling? No, decision tree don't need scaling. And what is the BFSI use cases of decision tree? Loan approval, fraud detection, credit risk. These are the use cases of BFSI domain, the banking, finance, and insurance domain. And what is the last summary? We will now understand the last summary point of this decision tree. Entropy means it measures the confusion, measure the disturbances, measure the randomness. Information gain is to choose the best question, to choose the best column. Decision tree, it is human-like logic. Gini is faster than impurity measures. Overfitting control way with pruning. Random forest, it is the ensemble of trees, yeah, and that is all about the decision trees. So in your machine learning algorithms, whenever your manager, your boss, or your client, or whatever, if you are doing freelancing, if you have a bunch of data set, then just look at the column names of that particular data set and analyze what we can do better to get the best answer. You have to calculate the number of rows, columns, and just try and do various experiments to get the better results. So that's it for today's video. If you like the video, please do like, share, and subscribe my YouTube channel. And definitely, I will try to make another video on most probably on what is random forest, because it is the next version of decision tree. After random forest, we will go for XGBoost. After that, all kinds of most widely used machine learning algorithms we will see in this playlist. So stay tuned, and thank you very much for watching my YouTube channel. Bye bye.